What is the meaning of phase-to-phase compensation in three-phase self-consumption systems with zero injection? Before understanding this concept, we should know that there are two ways to build three-phase self-consumption systems. On the one hand, we have facilities built with several single-phase inverters, and on the other hand, we have facilities with three-phase inverters. In the case of systems that can inject power to the grid, three-phase inverters are more recommended because the inverters will always work at the maximum power point regardless of the consumption that is happening in each of the three phases. However, in the case of systems with zero injection, it is necessary to regulate the power generated in each of the phases in order to adjust it to the instantaneous consumption. Therefore, both options, single-phase and three-phase inverters, present advantages and disadvantages. The first ones present greater complexity and price. However, in facilities with unbalanced consumption, where there might be large consumption differences between each of the three phases, they provide a higher self-consumption ratio. This is due to the fact that the decisions are taken by each of the inverters for each one of the phases independently. In this way, each phase will self-consume as much as possible, which significantly increases its self-consumption ratio. The second ones have a lower complexity and price. However, they tend to have a lower self-consumption ratio. This disadvantage can be minimized with what we know as phase compensation. Phase compensation consists of considering generation and consumption as two large blocks. Within the generation block, we find all the available PV energy, and within the consumption block, we find the total amount of energy consumed by the three phases. Let's have a look to an example to illustrate this functionality. Imagine a three-phase system with an INGETEAM SUN 100TL inverter at a time of the day with a high irradiation capable of giving us all its power. Let's also imagine that the consumption in each of the phases is 10 kilowatts in R phase, 50 kilowatt in the S phase, and 40 kilowatt in the T phase. As we can see, this is a system with unbalanced consumption. If the phase compensation option is not activated, the phase with lower consumption, in this case 10 kilowatts, would be taken as a reference by the inverter. Being a three-phase system, the inverter would generate those 10 kilowatts for each of the three phases. That is, a total of 30 kilowatts. In the first phase, the grid consumption would be zero, but in the other two phases, the grid consumption would be 40 and 30 kilowatts respectively. As we can see, despite of having photovoltaic energy available, we are forced to consume power from the grid in two of the three phases. Furthermore, the self-consumption ratio in this case is only 30%, because only that percentage of photovoltaic energy is delivered to the loads. If we activate the phase compensation option, the following would happen. As we have commented, in the consumption block, the sum of the power consumed in each of the three phases is considered. In this case, we would consider a consumption of 10 plus 50 plus 40 kilowatts, that is 100 kilowatts. This is the consumption that the inverter tries to compensate by producing a power equal to 100 kilowatts. In this way, a generation of 33.33 kilowatts would be obtained in each of the three phases. This results in an injection of 23.33 kilowatts in phase R, which corresponds to the sum of the power consumed by the other two phases, 16.67 and 6.67 kilowatts in phases S and T. In the case of activating phase compensation, the self-consumption ratio increases from 30 to 100%. Furthermore, this option is not only interesting in systems with unbalanced consumption, but it is also interesting in systems with unbalanced generation, where one phase might contain more PV generation than others. This is so in systems made out of several single-phase inverters, where one of the units might have a greater number of PV modules. As we can see, phase compensation is interesting to increase the consumption of PV energy in three-phase systems and therefore a better management of our facility. The next step is to ask yourself where and how we should activate phase compensation. We will start by installing all the necessary components for the correct operation of our system. For this, INGETEAM offers detailed information on its website about how to carry out this process. Next, we will proceed to configure the system, and it is at this time when we must activate the phase compensation option. To do so, we will need to access the corresponding menu in the software named INGETEAM board interface and activate it over there. Phase compensation is a measure aimed at making better use of your PV system. We hope you find it interesting.